All right, everybody, this is the video for 3-3 where we are multiplying by one-digit numbers. So you can see here, this is one digit. So I'm multiplying this one digit by some other digits. So we're going to just go quickly through this. We're going to be using place value to explain some of these. So in this one, it says use place value to explain each step in finding 3 times blah, 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 blah. Okay. So when you normally see something like this, a problem like this, you'll see it written like a standard algorithm problem. But for some, it's like, well, why do I multiply here, then here, then here, then like, what is the purpose here? So what we're doing is we are actually multiplying each place value part. So what it's asking is how we would use place value to do one of these things. Oops, sorry, I erased that and didn't mean to. Is what is 3 times 2,000? What is 3 times 700? What is 3 times 40? And what is 3 times 6? So it's just asking us to break these things down. So this one would be 6,000. This one would be 2,100. This one would be 120. And this one would be 18. Okay. If I added all these together, I would get the final product. So place value, when we're multiplying in standard algorithm, is just going and separating. We're multiplying that 3 by each part of that number. Okay. All right. Let's look at this next one. All right. So find each product, estimate to check if your answer is reasonable. So let's first do we want to estimate first or after? We'll do it after. Okay. So really what I'm doing on number 2, I'm going to do my work over here in this little area in purple right here. This is where I'll do all my work here. So we're going to do number 2. It's 23 times 4. When really what we're doing is 20 times 4 and 3 times 4. 20 times 4 is 80 because I have 20, 40, 60, 80. And then 3 times 4 is 12. If I were to put those together, I could find out that that was 92. Okay, so our product is 92. Let's estimate. This one is close to 20. This one we can keep 4. 20 times 4 is 80. Does that seem like a reasonable answer? We rounded down. If we rounded up, would we get something a little different? Let's see. I have 25. It's close to 25. 25 times 4 is 100. Our answer is right in the middle. So I would say yes. Our answer is reasonable. Okay. Ooh, I forgot to put my operating symbols there. Sorry about that, guys. All right, let's try another one. Let me erase this up here. We're actually going to do we'll do 3. Okay, so I have 378 times 2. So what we're going to do is we're going to separate out those place values. So 378 can be written as 378, right? If we were to pull it apart. So 300 times 2, 70 times 2, and 8 times 2. So I have 600 because 2 times 3 is 6, and then I have hundreds. 2 times 7 is 14 tens, and then 8 times 2 is 16. If I were to add these together, I would do 600 plus 140 is 740, plus 16 more would be 756. Okay, then you can do the same thing where we're estimating. This one's close to 400. 400 times 2 is 800. Is it reasonable to say that that's what it is? Yeah, I'd say that's a reasonable answer. It's pretty close. If it weren't reasonable, my answer would be like 327. Is 327 close to 800? No, then I would know I need to go back and fix the problem. Okay, let's try one last problem here. Let's do number 5. Since this one has several place values, let's look and see how we would separate that one. Okay, so I see that I have 1,740 and 6, and they're all being multiplied by 3. Oops, what in the world was my brain thinking there? They're being multiplied by 3. Okay, so let's go ahead and figure those out. 3 times 1 is 3, and we're talking about thousands. Okay, 7 times 3 is 21, and we're talking about hundreds. 3 times 4 is 12 tens, is 120, and then 6 times 3 is 18. We would add these all up, and we would get our final product. Okay, so really what we're doing here with finding each product with place value is finding their partial products. So this, while it seems like it would take a long time, it actually helps us to build when we're doing the standard algorithm. So if I were to multiply, this would be 18, 12 and 1 is 25. Whoa, not 25. 12 and 1 is 13. 21 plus 1 is 22. 2 times 1 is, 3 times 1 is 3 plus 2 is 5. So if we were to add this up, we would get the same answer here. All we're doing is showing you each of these separate parts. Okay? All right. For you guys on your independent practice with your workbook, you are completing numbers 6 through 13. And then, as always, you always are going to do the higher order thinking. That is always something you should aim for if you're working in class, is to do this one. Okay. If you have enough time to get through these other ones, I would love you to do all of these ones. But if you're running out of time, you need to do the higher order thinking. This is stretching your thinking just a little bit more using the same skill that we have practiced on all the other pages. Okay, and then when you're done, get your quick check done. All right, if you guys have any questions for me, please feel free to reach out. Okay, bye.